Welcome to the lecture on spreadsheet engineering and influence diagrams. Let's get started. Spreadsheet engineering is the process of designing, constructing, and testing spreadsheet models. While spreadsheet tools like Excel make it easy to jump into modeling, skipping the planning phase can result in flawed designs, bugs, and poor decisions. Careful planning and thoughtful design can save significant time and effort, improving both the speed and quality of the model while reducing errors. Complex decisions can be broken into smaller, manageable components. Influence diagrams are visual tools that represent these components and their relationships. They offer a conceptual model of a business problem. They show the logic behind the decision-making process. By visually mapping inputs and outputs, they help us understand how decisions are interconnected. Influence diagrams consist of two key elements. Nodes represent decision variables and are shown as ovals. Arrows indicate the influence that one variable has on another. The diagram starts with the target output variable at the top and continuously breaks it down into intermediate outputs and inputs. This hierarchical structure highlights how variables influence one another. To create an influence diagram, follow these steps. Start with the target output at the top. Identify the variables that directly influence this target output. Decompose each variable into additional inputs or components, ensuring each variable appears only once. Document the intermediate calculations required. Continuously refine and improve the diagram. This process ensures a clear and logical flow from inputs to the target output. A well-constructed influence diagram simplifies the process of building spreadsheet models by clearly documenting the logic and assumptions behind the model, making the model easier to understand for others, helping to identify and avoid errors as the model becomes more complex. Influence diagrams are also essential for auditing and improving spreadsheet models over time. Consider the case of Claire Wong, who wants to model her retirement savings over a 30-year career. The goal is to create a spreadsheet model that predicts her account balance based on disciplined contributions and employer matches. The influence diagram will map the relationships between inputs like salary, contribution rate, and return rate, and the target output, the ending balance. To create Claire's model, we use the following assumptions. Input the starting annual salary as $50,000 with a 3% yearly increase. Input the contribution rate as 10% of the salary. Input the employer match as 4% of the salary. Input the annual investment return as 6%. Initially, contributions and matches are calculated annually. Later, the model is refined to use monthly contributions and matches with equal monthly returns applied. The relationships in Claire's model are visualized on the left in the influence diagram, while the equations used to determine the variables are listed on the right side. These formulas link all inputs to the final output, ensuring accurate calculations. Using the influence diagram as a guide, the model is constructed in a spreadsheet with rows for years and columns for variables such as salary, contributions, employer match, and ending balance. Input variables are stored separately for flexibility. Clear labels and formatting ensure that the spreadsheet is easy to read and interpret. This organization allows for scenario analysis by adjusting input variables. As depicted on the slide, you can toggle between seeing the formulas inside of the cells and the results by selecting Show Formulas in the Excel toolbar. Influence diagrams and spreadsheet engineering work together to build reliable and transparent decision models. By clearly mapping inputs, processes, and outputs, these tools help avoid errors and improve decision-making. This concludes the lecture on spreadsheet engineering and influence diagrams. Thank you for your attention.